Morning students, today I am going to start with the first practical of EMI, that is determination of accuracy, resolution and hysteresis using analog meter. So the apparatus used in this experiment are DC power supply and analog multimeter. So using voltage measurement we will determine the accuracy, resolution and hysteresis. So there are three static characteristics. So these are the three static characteristics, that is accuracy, resolution, hysteresis. Where accuracy means the exactness of the obtained reading with the true reading. Resolution means smallest detectable change, and hysteresis means we can get the same value while increasing or decreasing the inputs. Now let's see how these static characteristics can be tested using voltage measurement. So here, so this is, so now let's see the experimental setup. So this is the experimental setup, that is power supply and analog meter. Let me show you. Yeah, this is the setup. It consists of power supply and analog meter. Now moving towards the observation table. So this is the first observation table where we determine accuracy of analog multimeter using voltage measurement. The tables includes actual voltage given by power supply, then measured voltage using voltmeter, and then we have to calculate the accuracy, relative accuracy, and then we have to find out the accuracy in terms of percentage. Okay. So this is the power supply. Okay, so and this is the analog multimeter which we will be using. Its range is up to 10 volt. Then we have power supply where we can supply power up to 30 volt of voltage and 3 ampere current. Now first see the connections. So here the negative of analog multimeter is connected to the negative of power supply, and the positive of analog multimeter is connected to the positive of the power supply. And when these connections are done, the first step is to ensure that the zero adjustment, which can be done using the this screw. Using this screw you have to set it to the 0 volt. Then also set the power supply to minimum using the coarse knob. So this is the dual power supply and we are using channel A of power supply. Now press the knob A here. So from the power supply we will provide the voltage, like voltage like 1 2 3, likewise we need to supply the voltage. Okay, now first we'll check for 1 volt. First we'll check for 1 volt using this coarse knob, adjust the voltage. So for 1 volt, the same voltage we will be measuring using the analog multimeter. So for 1 volt, let's see how much voltage we will receive at the analog multimeter. So if you can see, the needle points to the 1 volt. So analog multimeter also gives the same voltage. So for 1 volt, we are receiving 1 volt at the analog multimeter. On the analog multimeter, write down on the table. Okay, this is xn, and measured voltage using power supply is yn, and the relative accuracy we have to calculate like xn yn minus xn. It is 1 minus 1, sorry, 1 minus mod of xn minus yn upon yn minus xn upon yn, then it will become 1 minus 1 upon 1, then it will become, answer is 1. So if you multiply the output into 100, then you will get the 100% accuracy. Now check for 2 volt. Next volt. Now for 2 volt, for 2 volt, for 2 volt we are getting exactly 2 volt on the analog multimeter. So note down on the observation table. The answer will be same, 100% accuracy you will get. Okay. Now check for 3 volt. For 3 volt, for 3 volt we are getting 3 volt on the analog multimeter. So here also you can get the same accuracy, that is 100% accuracy over here. So from this observation table we can say that given voltmeter has high accuracy. Okay, now moving to the next observation table. So the next observation table, now the next observation table is to determine the resolution. So here we are using the same instrument, that is power supply and analog meter. So what you have to do, you have to first, there are two columns, column A and column B. In the first column you have to take the output of power supply on in terms of voltage and output of analog multimeter. So here we can, resolution means what? Smallest detectable change. So suppose if you are giving 6 volt from the power supply, so you need to check on the analog multimeter whether you get the same voltage or there will be a change in the voltage. So that smallest detectable change you need to get it in the resolution. You have to determine through in the analog multimeter. So first voltage is 6 volt, then 5.5, then 5.2, then 5.1, then 5.05, and then 5.0. So let's see. For first we'll see for 6 volt. Let's see for 6 volt here. So for 6 volt we are receiving 6 volt on the analog multimeter. So if you can remember here, each line indicates of 2 volt, each line of 2 volt, then 6 volt will give you the measured voltage on multimeter is 6 volt only. Now we'll check for 5.6 volt, 5.5 volt, sorry, for 5.5 volt we what will be the output. So 5.6 volt, what will be the output? So 5.6 volt we are getting, we are getting so here each line is of 2 volt, so here we are getting 5.5 volt. Here we are getting 5.5 volts. So note down this on the observation table. So here we are getting 5.5 volt. Now we'll check for 5.2 volt. So for 5.2 volt we are getting 5.3 volt on the analog multimeter. Note down on the observation table. Okay, now we'll check for 5.1 volt. Yes, 5.1 volt. For 5.1 volt we are getting, as it is fluctuating, so if you can see the for 5.1 volt we are getting 5 volt. This 4.9, this 5 volt. Okay, so likewise you have to calculate for the resolution. Now the next observation table is to determine the hysteresis. In the hysteresis, here first we have to voltage given by the power supply in increasing order in uniform steps. Uniform steps means what? Like in the steps of 2, or in the step like 1 2 3 4, or 1 in the steps of 2 like 1 3 5 7. Then we have to check for the voltage with the voltmeter. Then we have to again voltage given by the power supply in decreasing order. Then we have to measure voltage with the voltmeter. So first we'll check for 1 volt. For 1 volt we are getting 1 volt on the analog multimeter. Now we'll check for 3 volt. Now for 3 volt we are getting 2.9 volt on the analog multimeter. So note down, for 3 volt we are getting 2.9 volt. Okay, so now we'll check for 5 volt. So for 5 volt we are getting 5 volt on the analog multimeter. Note down on the observation table. Now we'll check for 7 volt. So for 7 volt we are receiving 6.9 volt. So there will be a little change on the measured voltage on analog meter. Now we'll check for the voltage given by power supply in decreasing order, like in terms of 7531 in the reverse order. So for 7 volt, what is the voltage we are receiving? Let's see. So for 7 volt, here we are receiving 6.9 volt. Now we'll check for 5 volt. For 5 volt we are receiving 5 volt we are getting 5 volt on the analog multimeter. Now we'll check for 3 volt. For 3 volt we are getting 2.9 volt on the analog multimeter. And lastly we'll check for 1 volt. So for 1 volt we are getting 1 volt on the analog multimeter. Write down on the observation table. I hope you have understood this practical, that is to determine the accuracy, hysteresis and resolution. Thank you.